Here we have a SAT math problem. Okay, let's go to the question. The figure below shows a square and a right triangle. What is the area of the shaded region? Since the given figure is a square, all the four sides are equal in length. We know that the length of this side of the square is x, then the length of this side is also the same x, and for this side also we have the same x, and for this side we have the same x. Okay, now let's consider the line segment over here. What is the length of this line segment? We know that the length of this line segment is y. To get the length of this line segment, we have to subtract this y from this x. Then the length of this line segment is x negative y. And since the given figure is a square, at each vertex will have a right angle. So here we'll have a right angle. Okay, now to get the area of this shaded region, we have to subtract the area of this right triangle from the area of the square. Okay, now to get the area of the square, we have to multiply the side by side. That is x times x is x square. So x square gives the area of the square. From the area of the square, we have to subtract the area of this right triangle. In this right triangle, we know that this is hypotenuse because it is opposite to the right angle. Okay, in a right triangle, apart from the hypotenuse, when we consider other two legs, one of the legs can be considered as the base and other leg can be considered as height. Okay, here we can consider this leg as a base and this leg as a height. We know that the formula to get area of a triangle is base times height divided by 2. Okay, here the base is x negative y and the height is x and it has to be divided by 2. So this gives the area of this right triangle. When I subtract the area of this right triangle from the area of the square, so it gives the area of the shaded region. So this expression gives the area of the shaded region. So that is the required area. Let me write it over here. So required area, that is area of the shaded region, is the expression we have over here. Now let's do some simplification. Let's assume this is an integer and it is a fraction. So here we do subtraction between an integer and a fraction. Whenever I want to do addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I am done with the multiplication, I can take this 2 as a common denominator. Okay, now let's multiply this x square by 2. Then we get 2x square. And we can take this negative sign as it is, and we can write this product x negative y times x as x times x negative y. So here we know that the multiplication is commutative. So even if I switch the terms out here, so it is still equal to this stuff. Okay, now we can take this 2 as a common denominator. Okay, now let's do some simplification. 2x square. We can distribute this negative x to this x and negative y. Then I'm getting a negative x square, positive xy divided by 2. When I combine 2x square and negative x square, I'm getting x square positive xy divided by 2. Okay, here for this one and this one, the greatest common divisor is x. We can factor x out. When we factor x out, we get x positive y inside the parenthesis divided by 2. Okay, now I got the area of the shaded region, that is x times x positive y divided by 2. We find this stuff in answer choice A. The correct answer choice for this question is A.